Hey everyone, welcome back to Algebra 2. We are here on page 15 in your notes packet, and today's learning target is 4.3.4, which is about independent and dependent events. So we're going to start with a do now that is on the 2.0 level. Go ahead and pause the video here and quickly determine whether each of the following events constitutes an independent or a dependent event. So question 1 says you roll doubles on one turn in Monopoly, then roll doubles again. And this would be an example of an independent event. The reason being that rolling doubles doesn't change the dice in any way. It doesn't change the number of possible outcomes that you have for the next turn. So one roll of the dice doesn't have any influence on the next roll of the dice. Question 2, you are out trick-or-treating on Halloween. You pull a piece of candy out of your bag, eat it, and then pull out another piece. And this would be an example of a dependent event. The reason being that once you pull a piece of candy and keep it or eat it, there's one less possible piece of candy in the bag, so there's one less possible outcome for that second piece that you pull. Question 3, you pick a card out of a deck, put it back, and then pick another card. And this is an example of an independent event because when you put the card back, there's still the 52 cards in the deck that you started with. So for your second pull, the number of possible outcomes has not changed. So these are 2.0 level questions, just deciding whether two events are dependent on each other or independent of one another. The 3.0 level target is going to have us calculate the actual probabilities. And this is called compound probability when we are compounding two different events. And the formula for that is pretty simple. When we have two different events, A and B, then the probability of A and B happening is equal to the probability of event A multiplied by the probability of event B. So we're going to be figuring out two probabilities and multiplying them together on this learning target. And the one thing to watch out for is dependent events. Then the number of possible outcomes changes, meaning that you may have to watch out for that and change the denominator for the second probability. So let's take a look at some examples. This is starting in box 2. A spinner has 8 sections and a die has 6 sides. Figure out the following probabilities if the spinner is spun and then the die is rolled. So remembering that the probability of our two events, A and B, is going to be equal to the product of the first event multiplied by the probability of the second event. And when we're spinning a spinner and rolling a die, these two events are going to be independent of one another. They don't influence each other in any way. Getting an 8 on the spinner doesn't change what you could get as an outcome for the die. So we don't have to worry about dependence just yet. But let's calculate some of these probabilities. The spinner lands on 5 and the die lands on 4. So we just need to find each of the individual probabilities and multiply them together. So the probability of the spinner landing on 5 is 1 out of 8. 1 out of the 8 sections of the spinner will give you 5. Probability of the die landing on 4 is 1 out of the 6 faces of the die. So 1 out of 8 multiplied by 1 out of 6. And when you're multiplying fractions, you just multiply across. So 1 times 1 is 1, and 8 times 6 is 48. So the probability that the spinner lands on 5 and the die lands on 4 is 1 out of 48. Next example, the spinner lands on an even number, and the die lands on a number less than or equal to 4. So again, this is an AND problem, so we're looking for the product of the two probabilities. So the spinner landing on an even number. Random numbers on the spinner are 2, 4, 6, and 8. So 4 out of the 8 sections. And then the die landing on a number less than or equal to 4. That would be either a 1, a 2, a 3, or a 4. So that is 4 out of the 6 faces of the die. So the probability of less than or equal to 4 is 4 out of 6. So the probability of both events happening is going to be the product of those two. 4 times 4 is 16. 8 times 6 is 48. And we do want to write these as simplified fractions when we can. So I notice that 16 and 48 are both divisible by 4. 16 divided by 4 is 4, and 48 divided by 4 is 12. Oh, and those can still be simplified a little further. 4 and 12 are both divisible by 4, so that simplifies all the way down to a 1/3 probability. So the probability of the spinner landing on an even number and the die landing on a number less than or equal to 4 is 1/3. A couple more examples with this spinner and this die. We're looking for the probability that the spinner lands on a number greater than 3 and the die lands on a 6. So the spinner landing on a number greater than 3 means we're looking at 4, 5, 6, 7, and 8. That is 5 out of the 8 sections of the spinner. And then this is an AND problem, so we're going to multiply that by the probability that the die lands on a 6. Well, the 6 is 1 out of the 6 faces of the die, so times 1 out of 6. And that gives us 5 times 1 is 5, 8 times 6 is 48. A 5 out of 48 probability. Next one, the spinner lands on a number less than 4, and so does the die. So on the spinner, the less than 4 numbers are 3, 2, and 1. So that's 3 out of the 8 sides of the spinner. And then we're going to multiply that by the probability that the die lands on a number less than 4. AKA a 3, a 2, or a 1. So that would be 3 out of the 6 sides of the die. And then if we multiply those together, 3 times 3 is 9, 8 times 6 is 48, and those are both divisible by 3. So 9 divided by 3 is 3, 48 divided by 3 simplifies to 16. So as a simplified fraction, we have a 3 out of 16 probability here. Now let's take a look at some dependent probabilities. So this question here in the start of box 3 says, what is the probability that you pick a blue marble, keep it, and then pick a red marble from the setup where we have 8 blue, 5 pink, 4 red, and 3 white marbles in the bag? So as soon as you're keeping a marble, we know that this is going to be a dependent event. So you'll have to watch out for the denominator or the number of possible outcomes changing when we go to do our second probability. So the first part is pretty easy to figure out. It's asking what is the probability that you pick a blue marble? Well, there are 8 blue marbles in the bag, so there are 8 possible blue outcomes out of 8 plus 5 plus 4 plus 3, 20 marbles total in the bag right now. So if I pick a blue marble, that is a 8 out of 20 chance. But if I pick this blue marble and keep it, that blue marble is no longer in my bag. It's out here, I've kept it. So now, when I go to pick for a red marble, instead of having 20 possible marbles in the bag to choose from, now there are only 19. So when I go to pick this red marble, there are 1, 2, 3, 4 red marbles out of 19 in the bag. So notice how, because this was a dependent event, my number of possible outcomes went down. So 8 times 4 is 32. 20 times 19 is 380. And those are both divisible by 4. So 32 divided by 4 simplifies to 8. 380 divided by 4 simplifies to 95. So this is an 8 out of 95% chance that you would pick a blue marble, keep it, and then pick a red marble. So I'm going to reset my bag of marbles here. Second question says, what is the probability that you pick a red marble, put it back, and then pick a white marble? So since we put it back in the bag, these are going to be independent events. The number of possible outcomes is not going to change from the first to the second probabilities. So what's the probability that you pick a red marble? Well, there are 4 reds out of 20 in the bag. And then, since I put the red marble back in the bag, there are still 20 in the bag to choose from. And if we're looking to pick a white marble, there are 3 of those. So that would be a 3 out of 20 chance. So multiplying those together, 4 times 3 is 12. 20 times 20 is 400. And those are both divisible by 4, which gives me a 3 out of 100, or a 3% chance that you'll pick a red, put it back, and then pick a white. A couple more examples with this marble scenario. Next one, what is the probability that you pick a blue marble, keep it, and then pick another blue? So we know that this is going to be a dependent probability, and that my number of marbles for my second pull is going to be 1 less than it was at first. So at first, right here, right now, there are 8 blues in the bag out of 20 total. So that first probability of picking blue is 8 out of 20. But then say I pull this blue and keep it out. That's gone. It is now out here. And now when I'm looking for blue a second time, there are 1, 2, 3, 4, 5, 6, 7 blues out of 19 in the bag. So the probability of that second pull would be only 7 out of 19. 8 times 7 is 56. 20 times 19 is 380. And those are both divisible by 4. 56 divided by 4 simplifies to 14. And 380 divided by 4 simplifies to 95. So this is a 14 out of 95 chance. One more marble scenario here. This time it's asking, what is the probability that you pick a white marble, put it back, and then pick a pink marble? Since we are putting this marble back in the bag, these are independent events. The number of possible outcomes is not going to change. So what's the probability of picking a white marble? Well, there are 3 whites out of 20 in the bag. So I pull the white marble, then put it back in. It's still sitting right there. And now if we're looking for the probability of pulling a pink marble, there are 5 of those out of 20 in the bag. So 3 times 5 is 15, 20 times 20 is 400, and those are both divisible by 5, which gives us a 3 out of 400 divided by 5, which is 80. So this is a 3 out of 80 chance that you would pick white, put it back, and then pick pink. So that's 4. We have one more scenario. This time we have socks in a drawer instead of marbles in a bag. So go ahead and pause the video here if you feel comfortable. Give these ones a shot on your own, and then you can hit play to hear my answer explanations. So here we're being asked for the probability that you pick white, keep it, and then pick red. So we know that these are going to be dependent probabilities, and my number of possible outcomes is going to change. So the probability that you pick white, well, there are 8 white socks out of 16 in the drawer. So the probability of picking white is 8 out of 16. But once I have picked this white sock, it is no longer in the drawer. It has been selected, it is gone, it is not there anymore. So now when we're looking for the probability of picking red, there are 2 red socks out of only 15 left in the drawer. So that number of possible outcomes went down by 1 because we kept out the white sock. So that is going to be 16 out of 16 times 15, which is 240. Those are both divisible by 16, which leaves us with 1 out of 15. Next one asks us what's the probability that you pick black, keep it, and then pick black again. So this is another dependent probability, and the number of outcomes is going to change. When we're first looking at the full drawer, there are 6 black socks to choose from out of 16 total. So the probability of picking black is 6 out of 16. But if I pull that black sock and keep it out, so that is gone, and we're looking for the probability of picking black now. Well, now there are only 5 black socks in the drawer out of 15 total socks. So probability 6 out of 16 for the first pick, 5 out of 15 for the second pick. So 6 times 5 is 30. 16 times 15 is 240. And those are both divisible by 15 at least. 30 divided by 15 is 2. 240 divided by 15 is 16. And that can be simplified one step further. 2 out of 16 is the same as 1 out of 8. So those are 2 dependent probabilities. Now we're being asked for 2 independent probabilities. This is asking what's the probability that you pick white, put it back, and then pick black. So the number of possible outcomes, the denominator of the fraction, is not going to change. So the probability that I pick a white sock out of this setup is 8 out of 16. If I put the sock back after pulling it, the number of outcomes has not changed in any way. So the probability of picking black is going to be 1, 2, 3, 4, 5, 6 out of the 16 in the drawer. So that gives us 8 times 6, which is 48, out of 16 times 16, which is 256. And those are both divisible by 16. 48 divided by 16 is 3. And 256 divided by 16 is 16. So the simplified fraction there is 3 out of 16. And one more here, we're being asked what's the probability of picking red, putting it back, so independent, and then picking white. So the probability of picking red, there are 2 red socks out of the 16 total. Number of outcomes doesn't change, the setup doesn't change because we pull it and then put it back. And the probability of picking white is 8 out of 16. So if we multiply those two together, that is 16 out of 256, which simplifies to 1 out of 16. And we have 2 more questions here. These are, again, dependent probabilities because both of them are talking about the fact that you keep it. So these are going to be dependent probabilities. the number of outcomes is decreasing for each pull. So initially, the probability of picking red, there are 2 reds out of 16 total socks. But if we pick that red and then keep it so that it is no longer in the drawer here, now looking at my new adjusted drawer, the probability of picking red, there is only 1 red sock left out of 15 socks in the drawer. So that's 2 out of 16 times 15, which is 240. And that simplifies to 1 out of 120. And the last example, it's asking for the probability that you pick white, then white again, then black, and each time you keep it. So here we have 3 different events. We want the probability of picking white, times the probability of picking white again, times the probability of picking black. So with the original drawer, everything present, there are 8 white socks to choose out of 16 in the drawer. If we pick white and keep it, that means that this white sock here is no longer an option. It is gone. It is on your foot. So the probability of picking another white sock, well, now there are only 7 whites to choose from and only 15 socks in the drawer. So it's 7 out of 15 that you pick another white. But assuming that you do, that second white sock is also gone. You've got a matching pair on your foot. But then you go back in there and pull out another sock. And this time it's asking what's the probability that we pull a black one. Well, there are right now 1, 2, 3, 4, 5, 6 black socks in the drawer. And we are down to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 socks to choose among. So that probability, 8 times 7 times 6, is 336 out of 16 times 15 times 14, which is 4,080. 40, 80. And that simplifies quite a bit. 336 out of 40, 80 simplifies down to 7 out of 85. So the probability, you have a 7 out of 85 chance of picking white, then white again, and then black. So the main things to remember here for this learning target are 1, that the probability of 2 events happening is the product of the individual probabilities. And the other thing to remember is that when you have a dependent event, you pick something and then keep it out, the number of possible outcomes has gone down by 1, so your denominator changes each time you make a pick. So that is it for today's notes. Go ahead and do my participation check, and then try some of the homework problems on your own.